Awesome. Well, welcome to CoChannel interference and its impact on Wi-Fi performance part 2. So in the first part of this webinar, we kind of split this into two pieces. And the first one, we focused on CoChannel interference and how to minimize CoChannel interference in Wi-Fi design. Today, we're going to take a look at how it actually impacts a wireless network. And I believe that we're going to do that through a series of live demonstrations. Jerry's got a whole bunch of APs plugged in behind him. And so he's gonna be going through some interesting stuff here. So with us today is Jerry Ola. Jerry is one of our product managers here at Ekahau. And then we've got another person with us here that's not me, which is Clayton Matthews, who is
Joel's been replaced.
I've been replaced. Not a potato.
I had to get creative. So I don't have the potato, but I do have the beard. So that can kind of be me.
Yeah, it works, man. Yeah, it works. In fact, I think a couple of people have asked us if we're like brothers or something like that. So I think that's happened. So anyway, Clayton is our sales engineer for North America. He's based out of Texas. And I think I'll turn it over to you guys to get the conversation going here.
Awesome. Thanks, Joel. Thanks, Clayton, for jumping on and helping tackle this topic or continuation of this topic of CoChannel interference. So the agenda, we'll say kind of loose agenda here for the webinar. We'll kind of see what rabbit trails we go down. But kind of recapping what is CoChannel interference. We picked this topic up, it was a few weeks back now, but we wanted to continue on since we didn't cover everything that we wanted to. And the biggest thing to me is I don't really feel like we walked away from that webinar really landing what are the actual effects of CoChannel interference. And when I say the effects, like how do we measure and kind of quantify, that impact of CoChannel interference? We often kind of talk about it as this arbitrary thing of, it increases airtime utilization and, decreases throughput and performance and those kinds of things. But, how do we really, measure that and quantify that? So we're going to hopefully be able to address that in today's webinar. And that's really where this kind of lab thing that I set up here comes into play. And we'll see. We'll do a little live lab and it could be a total train wreck or it could be amazingly awesome. We'll see. You guys can be the judge of that. We'll also discuss some additional ways that maybe we didn't get a chance to cover on the last one, or maybe we just briefly covered, and we'll try and build upon that. Couple housekeeping things before we dive into this. This session is being recorded. You are in a listen-only mode, and we do leverage things like the chat. We allow you to chat with all panelists and attendees there, so go ahead and locate that little drop-down thing on the chat thing, and if you want to interact with the audience and the Joel and Clayton here, use the chat there. But then also we have the Q&A panel, and we've been leveraging that a little differently this session, at least we were talking about before the webinar started some different topics that you guys might be interested in. So maybe we'll leave that up there for just another minute or two here. So those of you that are just joining, take a look at the Q&A panel, and there's been quite a few submissions of different webinar topics, and you can give those a thumbs up if a topic sounds interesting to you, and then we'll factor that into the next round of webinars as we build those out. Cool. All right. Well, let's.
So I'll leave all of our current recommendations in there for just a little bit longer. I'm sorry, Jerry. I think my audio cut out for a sec. I couldn't hear you, and so hey, it's CoChannel interference, right? Jerry was talking, and my machine didn't tell me that Jerry was talking, and so I started talking, and then we had a collision, right? Yep. So yeah, my collision avoidance is not working well today. I will leave all of the topics in there, the webinar topics in there for a couple of minutes, and then I'll go ahead and clear those out. So go ahead and get your votes in here in the next 120 seconds or so. Jerry, I'm going to shut up now and let you talk.
Appreciate it. I like to say that's Joel's 2.4 gigahertz showing.
Hey now.
Just to pick on him. We'll talk more about that. All right, so understanding CoChannel interference. So Joel, I'm going to need your, or Clayton, if you guys want to help me annotate this slide a little bit here. So, what is CoChannel interference? We'll just quickly kind of walk through this since we spent some time on this on the last part one, but just to lay the groundwork here, CoChannel interference And we've got an access point in the middle there. It's on, our dual radio. So we've got a 2.4 radio on channel 1, 5 gigahertz radio on channel 56. We've got, looks like 6 total clients connected to that AP. Well, what happens when these clients are all trying to talk to that access point? Well, each one of these, the AP itself has a transmitter. Each of the clients have a transmitter, and at least in the clients, those are typically going to be an omnidirectional transmitter. So even though the AP is nearby, those transmissions go in essentially 360 degrees around the client every time they're transmitting to that AP. Yep, all directions off of there. So that means any other access points that are nearby that are either, if in this case, it looks like all of our clients are on that 5 gigahertz radio, so they're all on channel 56. Every time one of these clients transmits, those signals are going off in all the directions there. And that means any other APs that are nearby that are operating on that same channel, listening on channel 56, transmitting on channel 56, they're going to have to contend for that airtime, right? So we've got limited amounts of channels, and the more devices that we have talking on a given channel, the more contention that's going to happen. Only one device can talk on a given channel in a given area at any one point in time. So if they do both try to talk at the same time, then a collision occurs and then a retry and all that kind of stuff. So you can see how things can get compounded and complex very quickly. So we're going to try and unpack all that, at least in a couple of different ways here throughout the webinar.
Hey, Jerry, just really quick on that last point. I mentioned this the last time. Even if 2 access points can't hear each other on the same channel, that doesn't necessarily mean that you're safe. Because if a client at the edge of the cell, if one of the access points can hear the client that's connected to the other access point, it can still cause co-channel interference.
Right on. And I see Frank has a hand raised in the chat. I don't know if that was by accident or if you had something. We could get adventurous on this webinar and use the allow to talk. So Frank, I'll go ahead and lower your hand. And if you intended to do that and want to jump on your mic, go ahead and raise your hand again, and we can give you allow to talk. And maybe we've got a point to add to that topic. All right, well, we'll continue on for now. Let's talk about the effects of co-channel interference. So I like to kind of break this down, and this is really one of those things that I think there's 2 main things here. There's looking at the effects of co-channel interference from a layer 1 perspective, and then looking at the effects of co-channel interference from a layer 2 perspective. And what we mean by that, layer 1 is the physical medium, right? That's the actual RF energy that's being transmitted and measured on the spectrum, and then the layer 2 side is more the packet level information, and there's going to be impacts that we can observe in both of those that can correlate back to co-channel interference and the effects of that. So on the layer 1 side, we're going to see an increase, using a spectrum analyzer, we can see an increase of utilization. We can also see things like increase of noise and then lower SNR as part of that. On the airtime side, we're going to see things, with a packet analyzer, increase in airtime usage, as well as potentially lower MCS rates, and then things like increased number of retries, as we just were kind of, inadvertently demonstrating with the audio issue there of Joel not receiving that transmission from me. Even though we're using the same channel, he didn't hear me talking. He started talking and then talked over the top of me. A collision can occur, and then we have to retry that transmission. Same kind of thing happens in Wi-Fi. So yeah, we'll kind of break down each of these, and this is my hope is that we can really dive into this whole utilization or the effects piece here, and do some demos and actually try and measure these results live. I've created a lab here behind me with these access points where I've got 4 APs. 3 of them are on the same channel, and then 1 of them is on a separate channel. And we'll see. And I'm in a pretty controlled environment, so we can be pretty aware of what's happening here. So yeah, let's talk about management frame overhead as part of this as well. So one of the tools that I wanted to talk about is this SSID Overhead Calculator that I think is really useful. This thing's been around for a while. Andrew Von Nege put this together, and it's on his blog here, Revolution Wi-Fi. There's actually 2 different versions of it. There's the Excel document, and then there's also an iOS application. And let's use this as kind of our starting point here to talk about, just to visualize, what's happening here from an SSID standpoint. So what I'm going to do is pull up the SSID calculator, and we'll first look at kind of the math behind this here. And let me go out of full screen here so we can pull this up. All right, so I've got the SSID calculator here pulled up in the Excel document. And if you haven't seen this before, it's pretty slick. So this is really, using math, right, to understand what happens here when we have things like how the management overhead piece of the Wi-Fi correlates to and gets amplified based on co-channel interference. So on the left side here in this chart, it talks about number of access points on a channel, and then across the right is the number of SSIDs that are deployed. So this isn't even taking into consideration putting any clients on the APs, but purely just from a standpoint of management overhead and the number of APs that are all consuming that channel. So if we look at this here, this is kind of worst case scenario of we've got a 2.4 radio, it's operating at its lowest data rate, which is by default the case. I actually even did reduce the beacon frame size because I don't have a lot on the lab environment that I've set up here. So this would even be worse in a if you're supporting some more advanced technologies, different security implementations and things like that. You're going to have larger beacon frames, potentially more information elements in there, which is going to equate to even eating up more airtime. In my situation, I don't have those, so I kind of matched up with what I was seeing in the beacon frames from these APs. And then we've got so we've got number of APs on a channel, number of SSIDs. So if we only have, if we have no co-channel interference is what this is indicating here, we can actually get away with, 6 SSIDs on there and chewing up less than 10% of the airtime, which is, pretty reasonable. So my management frames there are essentially eating up less than 10%, still, almost 10%. So the fewer SSIDs that we can have deployed, the better. Usually, we look for around more like 3 SSIDs. And even, then if we have 2 APs even using the same channel, we're still at that 9%, less than 10%. But you can see how quickly that gets compounded. There's many environments, if you've done surveys, where it's very common that I'm seeing 6 APs or more on a given channel. And even at, only having 3 SSIDs on that channel or on each of those radios, we're already chewing up 30% of our airtime, and that's before our clients have even connected to the network. So now we're talking, utilization is going to be pretty high. All right, so this is all great, from a math standpoint, but what I thought would be really interesting, and this is where we'll see how things work out here, but I've got Ekahau pulled up, and I've got my Sidekick plugged in, but not powered on. So let me power that on quick. And what we're actually going to do is I'm going to try and show you here live, and let's see how closely this ends up matching up. I literally did this comparison once just recently. So let's see what this ends up looking like. And actually for now, just to make sure my client device isn't impacting these results, I'm going to turn off my internal Wi-Fi as well. So the Sidekick is starting right now. I've got these APs behind me here. And as I mentioned, 3 of the access points are on channel 11. And then 1 of them is on channel 1. And then I do have just some other things audible on channel 6. Thankfully, I had 2 channels that were completely, to my control in the environment that I'm in right now, where there was no other radios on there. So we have a pretty clean environment here to kind of use. And notice right off the bat here, check out the spectrum utilization on channel 1, which is my no CCI channel. And you can see there's just 1 radio audible on there. There's 5 SSIDs deployed on that 1 radio, but no co-channel interference. And then if we look down here at channel 11, we've got 3 radios that are audible and 5 SSIDs on each of those. No clients connected to either of these APs. And notice the difference right off the bat here before we even deploy this network and start getting clients to connect. What's happening to our airtime. So, again, this is going to relate to, the throughput of the network as well as the capacity. If already 30% of our airtime is consumed just by management traffic, that's a huge decrease in the amount of, kind of capacity that we can support on that channel. So yeah, and this is really, what we would expect to see, right? It's essentially kind of 3 times the amount of utilization because we have 3 times as many APs. So if we go back to our chart here, on channel 1, I have 1 AP audible and 5 SSIDs. According to the math here, we should be right around that 8% or so utilization. And if we flip back to Ekahau here, we can see that, is matching up in the real world. So I'm using so just to, I guess, kind of explain here, if you're not familiar with Ekahau's products, what I'm using is Ekahau Pro with the frequency monitor view. And then I've got my Ekahau Sidekick plugged in here using the spectrum analyzer and the Sidekick to measure the layer 1, that RF energy. And we can see that's matching up almost, identically with what the math is showing in the SSID calculator. So that should give you at least some confidence that this SSID calculator, the math that Andrew's done to build this thing, is matching up with what you should be seeing in the real world, at least in this kind of controlled environment. And then to look at the other one on here, if we look at channel 11 again, you can see we're right around that 30% utilization here on channel 11. And again, no clients connected. This is purely management traffic. And if we flip back over to the SSID calculator, we can see, with 5 SSIDs deployed, and we have 3 radios audible. This is saying that we should actually be right around that 23% or so utilization. My beacon frame size might be a little bit smaller than what it actually is. Here I did actually do a Wireshark capture, so let's just pull one up here. So I just did this previously, and here's one of the beacon frames here, and actually is about 240 bytes, not 160. So if we bump that up, it'll probably even match a little bit closer. Yeah, so there we go. With 3, it's saying we should be right around 3 Ps, around 19% utilization. So yeah, we're seeing, with 5 SSIDs, it should be right around 30% utilization, which is what we're seeing. So yeah, kudos to Andrew with his math there. It is matching up very closely to what we are seeing in the real world. So that's the management piece of that, right? So if we flip back over to our slides here, if you want, I'll drop these links into chat if anybody wants to try these out, and that way you can load these up. There is an iOS app as well, and if we want, I can show you guys that too real quick, because I did connect my iPad, so if anybody wanted to see that. But there's the links to those if you want to play around with those and check those out. Those are really useful, I found, too, with speaking with customers, just being able to explain why they need to reduce the number of SSIDs in their network and the impacts of that. So yeah, if you guys want to see the SSID Overhead Calculator app, let me just share my...
I think so, yeah. John threw something in the chat saying, asking if anybody's used it. He says he has it and it's very handy. I think it'd be great to look at that.
Cool. Let's try this out. More live demos.
Man, you're just getting dangerous today, Jerry.
How many different things is Jerry going to demo in one webinar? He's going to hit like a record.
I'm just going to keep demoing things live until something just completely breaks.
Or until we just run out of things to demo. He's going to be demoing Notepad pretty soon here.
So this is on my iPad. Actually, it looks kind of cool too. I mean, especially like to take this to a customer site. I think this is pretty handy. So this is actually built by Ryan Adzma and Andrew, if I remember correctly. So they kind of did a little collaboration thing. So Ryan's the iOS developer that did the coding, I think, for the iOS app, and then Andrew obviously did the math and stuff for it. But this is, it has a nice little visual for it. Hopefully you guys can see this okay. And yeah, same kind of things where we can, choose our data rates. We can choose the beacon frame size. We can choose the interval, CCI, number of APs. So yeah, very similar. And yeah, you can see, we're looking at 27% utilization right now with a 200 byte beacon frame. And as we looked at it, was about 240. So you can see as the beacon size increases, so does the utilization. And that's just to do with, what kind of information elements, what's being advertised in those beacon frames. All right, so that covers the management kind of overhead piece. The next thing I wanted to talk about was around the MCS rates. And actually, I guess while I've got this SSID Overhead Calculator pulled up here, let's also just take a look at, data rates. So, we talk about pruning kind of low data rates and, what kind of benefits that provides us. If we're looking at this purely from a airtime utilization and how much utilization is on the channel, we can see this very quickly. Let's say we're going to prune off even just not a ton, but just go from 1 megabit per second to 6. And we're going to say all of our management traffic needs to go out at by default, it's going to go out at the lowest supported data rate. So if we say we're not going to support anything lower than 6, that's going to have a huge impact on our utilization, right? Even let's just get, just to compare, just go from 1 megabit per second to 2 and notice the difference. So back to 1 here. So this is at 1, 30% utilization. Even if all we can do, for some reason we need to support some really low data rates, even if we just chop off that 1 megabit per second, look at the huge impact on that overhead there. We can drastically reduce our overhead just by making a slight change like that. So even if our network isn't maybe designed to be able to support 12 megabits per second or 24 megabits per second, doing some simple things like pruning, even just 1 megabit per second and raising the bar to 2 megabits per second can have some pretty huge impacts on the performance. Obviously, we're looking at, B, technology now, and most of the time we're going to be working with things like A. And yeah, you can see, just moving over to 5 gigahertz, we're already starting at a much better place where, 6 megabits is the lowest supported. But then we can do the same thing over here. Maybe we bump this up to 12 megabits per second as our low data rate. And you can see how we can further kind of fine tune and optimize things there. So this is, right away, on 5 gigahertz, even if we take the whole, lots more channels to work with out of the equation, and maybe we're only able to use certain parts of the world and stuff can't use all the channels, just being on 5 gigahertz and those faster data rates is going to have a big benefit right there.
Hey, Jerry, a quick question from Sean through the chat here. How are you discovering the frame size? Are you doing a PCAP and then looking at that in Wireshark?
Yeah, so very simple. That's, as far, if you're not a packet head per se, that's one of the easiest things I think that you can figure out, because all I had to do to get that information is do a quick packet capture. That's really the biggest challenge, probably, is getting the packet capture right. If you have a Sidekick, it supports packet captures now as part of Echo Connect. But if you have a Mac, you can also leverage something free like AirTool. And you're just going to do a quick packet capture on the channel that, there's going to be some of those beacon frames. And then all you're doing is looking through, with something free like Wireshark, those beacon frames here. And I can see I've got a beacon frame here, and you can see the length of the frame. So it's 245 bytes.
And that depends on the length of the SSID, right? The length of the frame?
Length of the SSID name is going to be part of it, but also it's going to be the information elements in there, right? So like we'll notice like AP
names for Aruba and Cisco, things like that.
Yes, exactly. So that's a good point. Like one of the things as Wi-Fi engineers that we really like is like the beacon frames to advertise what the AP name is. And, we argue like, why do they not just provide that by default, or why is that not turned on by default? This is part of the reason, because the more things that we have advertised in a beacon frame, the more airtime it consumes, the longer it takes to transmit. It may be, a byte or two of additional information, it might be very minimal, but, it all adds up, right? There's, the more information that these beacon frames are advertising each time they're sending them out at, every 100 milliseconds, 102 milliseconds, that's all additional airtime that gets consumed. Which then compounds, based on the CoChannel interference. If we have, 5 different radios audible in a given area, that can get compounded very quickly. All right, so I talked about the MCS rates, or at least the data rates piece of it here. Let's see, is this still loading up? 1 second, it's still coming up on my end here. But yeah, we talked about the MCS rates. I got a couple other links here that you might be interested in checking out. The IT Rebel, I believe that's Scott Lester's blog. He, in my kind of prepping for this webinar, discovered his blog post that he put together on this that was pretty interesting, which then kind of led me down a little bit of a rabbit trail of this white paper, research paper that he referenced in his blog post about how the effects of CoChannel interference can impact MCS rates. This is one that if we have time, we can try to do. I actually wasn't able to replicate this. So this is one that I would say, and maybe even kind of turn to the audience if you've seen or measured anything like this. But yeah, I wasn't, in my just kind of quick testing in this lab environment, I wasn't seeing any impact to MCS rates. MCS rates are typically derived off of SNR. So I guess if you had enough noise caused by the co-channel interference, and maybe I just don't have enough to kind of generate in this lab environment to see the results of that. But yes, apparently, according to these kind of articles and this research, you can actually see a negative impact to MCS rates based on co-channel interference as well. Which I think does kind of make sense to me as well, because if you're having a lot of co-channel interference, you could be seeing a lot of collisions or more collisions happening, which then increases retries, which then the client devices may, as part of that process, rate shift down to a lower MCS rate and use lower data rates. Joel or Clayton, any comments on any of those topics?
Nothing from here, but lots of good information. And I was surprised. You and I were talking about this a little bit yesterday about how co-channel interference can actually influence an MCS rate and drag the MCS rate down. That surprised me. I did not expect that. I thought that MCS rates would be driven down typically based on retries, as a client device is failing to get, as a client or an AP is failing to get a frame acknowledgement back from the device on the other end. I thought that is what would cause an MCS to come. I think it is one of the things that causes MCS rates to drop. I didn't know that co-channel interference would do that, though. And I do recommend checking out this blog post that Jerry found by our good friend Scott Lester. It's very well thought out, cites lots of other sources, which I think is really cool. And I would just highly recommend giving that a read. Jerry has placed that in the chat.
We did some demo stuff already, kind of jumping around a little bit here, but we can do some more demo. Let me see, what was the, okay, so let's talk a little bit about things that contribute to CCI. So we talked about low data rates. What's some of the other kind of low-hanging fruit? Obviously, a bad channel plan, is probably number one that I would say contributes to co-channel interference. Bad AP placement. Clayton, why does bad AP placement impact co-channel interference?
Well, I mean, if the APs can hear each other really well, like down hallways, for instance, I've got basically just a channel of a reflective tube, so my access points can hear each other really well. Weren't we talking about this yesterday? And I might be stealing from the future, but in large open environments as well, right?
Yeah. What are the results of that? Why in a large open what does AP placement have to do with large open environments in co-channel interference?
Well, I mean, in large open environments, again, everything can hear each other, like conference centers, for instance, right? And so bad AP placement could come down to an antenna selection as well. So it's not necessarily bad AP placement; it could be bad antenna placement, right?
Yep. John made a comment in chat there. How to avoid open air? You would have to drop power way down, right? So yeah, certainly reducing power is one thing. Let's actually talk a little bit about that. I'm gonna actually skip over this slide for now, and let's jump to this kind of mitigating co-channel interference then, because I think that's a nice segue into this. So I broke this down into two different buckets here. We've got our coarse tuning and our fine tuning. Usually we like to start with the fine tuning. If you're inheriting, this is obviously post deployment, right? So hopefully you can just avoid all this kind of stuff up front if you properly design the network and engineer this right the first time. But if you're inheriting something that has a massive co-channel interference, what are some of the things that we can do? So I like to think of the ones on the left here are fine tuning. That's our more lower hanging fruit, easier kind of things that we can do. The coarse tuning, the reason why I bucket those ones into coarse tuning is because those are a bit more drastic. Usually there's some more cost involved in those, where the fine tuning is more changing settings, right? Clicking some knobs and some buttons to improve things. But yeah, on the coarse tuning side, that's usually, you're talking about bringing on like, somebody to come in and physically move things. You're making some kind of physical change in the environment, either moving APs, replacing APs, installing different antennas. There's a lot of costs involved. It sometimes is the necessary thing to do if the fine tuning piece isn't going to completely mitigate those issues. But yeah, to Clayton's point about, AP placement, I would say, equally with the AP placement part that's important is, the antenna part, especially in this open environment. We can start with things like, if you've got the APs on the ceiling and you've got omnidirectional antennas, certainly, lowering the transmit power might help mitigate some of that co-channel interference. But honestly, if it's a big open space and you're dealing with just free space path loss and have no obstructions, physical obstructions to kind of contain that signal, lowering the transmit power even all the way down to the lowest setting isn't going to do you a whole lot of good. We're going to have to do some more coarse tuning there. We're going to either need to lower those access points, down from the ceiling. We're going to need to maybe put directional antennas on those. Maybe even need to disable some of the radios, right? Or maybe even remove some of the access points. One of the projects I was involved in a big open warehouse, one of the first, I did a site survey, of course, first, and then realized, we've got co-channel interference everywhere. And basically what ended up happening is it was a rip and replace where they pulled out all the old access points. They put in all these new access points with external antennas. They spent all this money on these really kind of expensive, higher gain omnidirectional antennas, and then put them 30 feet up in the air in a warehouse. And they just had co-channel interference everywhere, even though they were using the automatic radio configuration, the auto RF features, and it turned the power down all the way. It still had co-channel interference everywhere because it couldn't turn the power down far enough with these higher gain omnidirectional antennas. So in that situation, the recommendation was to remove like almost half of the APs, maybe about a third of them. We basically started by just unplugging, the APs was pretty much the immediate solution to get things working again. We strategically unplugged about like a third of the APs, and then all of a sudden magically everything started working again. The auto RF capabilities started, kicking in and dialing up the power on some of the radios and was getting enough connectivity. But yeah, co-channel interference was just bringing everything to a grinding halt. As we looked at on the utilization, if you got a big open space like that and you've got, 5 SSIDs deployed and you've got 10 APs, audible, and they can all hear each other on the ceiling, that's just going to bring the whole channel to a halt very quickly, and you haven't even gotten a client to connect yet. What else am I missing? Anything? I see a lot of activity in chat. Anything on this list that's missing, or anything we should talk about? Any other ways of mitigating co-channel interference?
I really like. This is the first time I've seen. Yeah, this is the first time I've seen this slide, Jerry. I really like how you've categorized this in the fine tuning and the coarse tuning. That's really cool. I'm gonna steal that for future presentations, I think.
Yeah, I think a static channel plan in the fine tuning. Static channel plans are always preferred, right? And I see some activity in chat around Ekahau and the automatic channel planner and all that sort of thing. But it's environmental dependent, isn't it? If you go and take the time to set up a static channel plan and you're in an area that has neighbors and your neighbor moves in and just does whatever they want, there goes your static channel plan, right? But if you're in like Jerry's basement, for instance, where he can control the channels because those are the only ones that can be heard, then he can, do whatever he wants. So
I think there is potentially a lot of debate around static channel plan versus using whatever automatic stuff your infrastructure vendor provides. You hear the argument both ways. Like if you use a static channel plan, well, if some interference shows up, now your APs are unable to adapt and move over to other channels. Whereas, we've all seen some situations where maybe the automatic stuff will kind of back the whole network into a corner where pretty soon you've got all your stuff back on one channel anyway. So interesting. It's an interesting discussion, an interesting debate. I don't know. My tendency on this one is to say it's kind of situational. It just kind of depends on, are you there actively keeping an eye on the network? Do you need it to be a little bit more? Do you need it to be more automated? Just what are your needs?
Yeah, how big is the network?
Yeah,
right. Because channel interference. We're having this webinar about channel interference and how bad it is. But I mean, at the end of the day, wireless is designed around things like co-channel interference, right?
it is. It's totally amazing how 802.11 is so resilient, how much it can handle. I mean, it might not work great, but it really is amazing how, you throw you throw Wi-Fi devices into an environment where there's a bunch of adjacent channel interference and co-channel interference and non-Wi-Fi interference. It's incredible, really, that it keeps working. Maybe not well, but it will continue to work. It just amazes me.
Gary, do you have that data from Cisco Live?
Yeah, I was actually just thinking of that as well. Let me see if I can get that project file pulled up here.
Yeah, so we captured some data at Cisco Live, and in the data that we have here, the utilization in that conference hall with all of these wireless devices, all these clients walking around, all these access points that can be heard, never goes above, like 60%? Was it?
Yeah, it was at least from the areas that we measured it had very impressive utilization, and a lot of that. Let's look at Clayton and I, and actually Joel, were all just at Cisco Live, and obviously very dense AP deployment. I don't have a great project file put together this, but I'm just going to use this because it has some data in there, and we're just going to analyze the data that was captured here. So when we were at our booth, we did some survey and used the survey for iPad and the sidekicks, and just walked around, taking measurements, kind of demoing the tools here. So what I'm going to do is I'm just going to do a quick select on the CLUS APs here and mark those as my. And then let's take a look at the RTFM view here. We'll look at the real-time frequency monitor and see how these radios were configured. This is in the world of solutions. So super dense area of APs, not just from Cisco's own event APs, but also all the other vendors and stuff that were there with their booths and, demoing things, and lots of RF in the air, right? So I'm going to flip over to the survey side of the tool here, and we're going to look at some actual survey data. And let's actually take a look at, let's just take like a measurement here.
And it's kind of funny because you're not actually correlating data to a proper location on the map. You're just looking at the raw data that was captured, the Wi-Fi scanning data and the spectrum analysis data, correct?
Yep. Yeah, exactly. So we're just using this as a data kind of reference here of what was audible, where we were standing, where we took this measurement. So one thing that's pretty interesting is, let's do this right away. I'm going to filter down and just show you the the channel plan here, if you will, for the CLUS network. And this is what was audible, and at one of these data points that was collected here. So we've got all these different radios, and you might look at this. Let's turn off the density view so we can make this a little easier to see. And you look at this channel plan for the CLUS network, and you might look at this and think this. I don't know. I guess, yeah. What do you guys think when you see this? Does this look like a good channel plan? We're not using certain channels. We've got other channels that have more APs on them than others. This is probably using, I would guess that, yeah, actually, I think I was in Jim Florwick's session, and he talked about the network design there for the event, and that they did use RM, an auto RF to do this. So you don't have to use a static plan, but if for whatever reason the auto RF, maybe the environment isn't conducive to it or what, that's something that you could potentially do to mitigate co-channel interference. So I'm not saying you have to use that. Certainly the auto RF capabilities potentially can do a good job of it, but we need to kind of, set some bumpers on it. We need to fine tune it, and we need to maintain it and make sure that it is continuing to do its job. And I believe actually the way that Jim had said is they used auto RF to come up with the channel plan, but then they locked it, right? So it's not constantly adjusting throughout the day. Maybe he said they did it like, had it make changes every 24 hours or something like that. But I believe it was locked to a certain channel plan continuously throughout the day, and wasn't constantly changing. The whole rock concept, right? Of you're going to be the rock that doesn't move, and you're going to let everybody else that plugs in their consumer grade equipment or whatever move around you. And we can see that effects here in the channel plan. So notice we've got certain channels aren't being used, right? We have no APs from Cisco on channel 36 and 40, and then on some of these are 120, 124, 128. Anybody in chat know why these channels aren't being used? I'm guessing somebody that works at an airport might know why those channels are staying away. Yep, there you go. Joey, I think, was the first one to answer weather radar. So yeah, CLUS, the event there was pretty close to an airport. So typically those channels, or often those channels, are not going to be available to you if you're near an airport or near a weather radar.
Jerry, remember that one time we tried to stand up an AP at Aruba Atmosphere, and we were like, channel 120 is free, no one's using it, and we put our AP there, and it keeps moving away, and we're like, what is going on? And it took us like a good hour to figure it out.
Yeah,
good times.
Yeah, that was in Vegas. Yeah, we were, we could see the airport from the window, and we were not going to. Actually, surprising though, I'm pretty sure we were able to use like 120, 124. It was just 128 that was getting DFS hits and wasn't able to use. So yeah. Anyways, without going on that rabbit trail too much further, you can see some channels aren't being used, right? So now let's flip back from any SSID flip from CLUS to any SSID, and we see a drastically different story, right? Same measurement, same location, but now we're not filtering on any SSID, and now we can see, hey, that auto RF is actually doing a pretty good job here, because on channel 36, 14 radios audible, on that one channel right there. And then also on channel 40, we've got 6. So you can see there's quite a few APs and at some pretty loud volumes here. So definitely there's some intentionality behind that of why it's avoiding those certain channels. So yeah, you can see how it, does look at that and sees if it sees a lot of interference on a certain channel, it's going to avoid that. Yeah, and good point, Joey. And you're also seeing some of these even working on 80 or 40 megahertz wide channels as well. And you can flip over to the radio. So yeah, let's actually do that. Let's flip over to the radio side and take a look. So here's the Cisco APs. These were, looks like, actually look at that. We're even seeing some different data rate configurations. I didn't notice that before. I'm kind of curious why certain APs appear to be using have lower data rate supported and some don't. But it looks like a lot of them were pruned up to 18 megabits per second as the lowest supported data rate. So again, going back to that SSID and that kind of management overhead calculations we were looking at, this is saying that all of those management frames, all those beacons are being sent out at 18 megabits per second. So that's going to really help, mitigate kind of the effects of co-channel interference, because it's going to get those management frames on and off the medium that much faster. And we can see that as Clayton was mentioning on the spectrum side here, we can look at, what was the utilization on the channel there. So let's actually look at the channel health side and see, at least at this point here. Yeah, I mean, look at this. You're seeing like 0 to like less than 10% utilization on almost all the 5 gigahertz channels. So even with all these radios, things are talking fast enough and getting on and off the medium that the utilization is still staying really low. Another thing to note is on the 2.4 side, you want to see how many CLUS, Cisco Live, Cisco radios they had on 2.4. You flip over to the CLUS network, and all of a sudden everything disappears. They had 0 radios using 2.4, so this was completely a 5 gigahertz only network. So another thing to consider, we've only got 3 non-overlapping channels on 2.4, so sometimes the simplest solution is just to avoid 2.4 altogether, because
Jerry, what about my $60 Android phone? Well, it won't work.
Yeah, you're gonna need to upgrade. So that's one of the coarse tuning points that we talked about.
Throw away Joel's $60 Android phone. Got it.
Well, it's not just your phone, Joel. I mean, there's a lot of clients out there, like the original Chromecast, the smart TV that I bought last year that just have 2.4. And sometimes I look at it and I go, really? Like, you can really only see 2.4? Like, it's a little bit ridiculous. Another one, Jerry, if you pop over to 5 again, you'll notice.
Before I switch back over to 5, notice this though real quick, as I switch back to any SSID. Remember, Cisco had no radios on 2.4. However, we're seeing all sorts of co-channel interference on here. Look at the noise levels on 2.4. So that's a lot of non-Wi-Fi interference. So that's adjacent, that's non-Wi-Fi interference. And then you can see what the utilization is on the channels, across the entire 2.4 gigahertz band. So totally makes sense why Cisco wouldn't even try to put any radios on that band, because it's just going to be a bad client experience that they didn't want to even try to support. And what were you saying, Clayton? Switch back over to 5.
Oh yeah, I was just saying that one of the channels that isn't being utilized is channel 144. It comes down to the client support of channel 144 again.
Yeah.
So that one's not so much that it's unusable. It's that not a lot of clients can see it.
Well, not even just not a lot of clients. A lot of APs don't support it either. I'm not sure which models of Cisco APs do even support channel 144, but yeah, there's a lot of even though channel 144 is allowed in the US, there's still a lot of countries that don't allow 144, but a lot of APs still don't have channel 144 support. Cool. All right. So I see we're at that kind of 45-minute mark here. I see there's a lot of questions to answer. I have some, like I said, loose agenda here that we can keep going down some of these topics. But if there's anything else we want to go into live demo-wise or questions, maybe this would be a good time just to try and hammer through as many of these questions as we can.
Yeah, let's go ahead and jump into some questions. For whatever reason today, Jerry, I am on 5 gigahertz right now, and I'm watching my pings, and it's not going well. So if my voice starts getting choppy and stuff, then just cut me off, and we can transfer the responsibility of the questions over to Clayton or something like that. So I'm just going to start at the top and work our way through some questions here. First question from Francisco is, why are we always talking about co-channel interference between APs? Clients also cause co-channel interference. I agree. I think that there are more clients than APs, and so why are we always talking about that? Any thoughts on that?
I do have some thoughts on that. It's a really good question, and it's certainly something that we do need to take into consideration, but it's also something that we don't have a lot of control over. As we did briefly kind of mention, in the beginning when we talked about what is co-channel interference, certainly the clients and where the clients are, need to be kind of taken into consideration, but we don't really have a whole lot of control because the clients, one, are portable, they're moving around, and two, we can't strap a directional antenna, on your client device like we can with an AP. So from a mitigation of co-channel interference standpoint, everything that we can do to mitigate co-channel interference is really more on the AP side. I think the only thing that on my list here of mitigating co-channel interference would be under the course tuning of upgrading your client devices to be 5 gigahertz capable if you do still have 2.4 gigahertz only clients in your environment. Beyond that, what else can we really do when it comes to the client? So that's why, unfortunately, we don't really have a whole lot to really talk about there.
Joey made a great point in the chat just now too, that most traffic is downstream too. And so and this is not always true. And Joey mentions, like exception to maybe voice over Wi-Fi. And I'm sure there's some other applications here as well. But if the majority of your traffic is, I just dropped a whole bunch of packets there. I don't know what made it through, but if you've got a lot of downstream, then yeah, the APs are going to be what is causing the vast majority of your co-channel interference.
Good question.
Cool. Well, let's move on to the next one. Sorry if my audio cut out there, guys. I just don't know what's going on today. It's rough. I need a sidekick. If only
Zoom's handling it well. It sounds good on my end.
Really? Okay. Well, I just saw it. Seriously, I'm pinging my gateway, and I lost a ton of pings there. It was bad. So cool. Let's move on to the next one. Boss has a great question here. He asked this one really, really early on in the webinar. He had a question around hidden node problems. His question is the hidden node issue also a form of co-channel interference?
I had a feeling that one was going to come up. Clayton, you want to take that one?
I don't know. I mean, it's not really a form of co-channel interference so much as it's that the clients can't hear each other talking, right? So that's why you turn on RTS CDS so that the clients are aware, so that in one area the clients are all aware of each other. And so in that form, the whole CoChannel thing that we're talking about takes into account. But when you got that one client off to the side over there, nobody else can hear that guy talking, right?
Yeah, I did think about this one, and the thought that I had behind it is I would say it's not a form of co-channel interference, but it could contribute to the kind of negative effects of co-channel interference, right? Because if you have a hidden node problem, you're going to probably have higher retries. It's going to cause collisions, which could be higher retries, and basically kind of amplify, a co-channel interference problem. But I wouldn't say it's necessarily a form of co-channel interference.
Just to make sure that everybody's on the same page as to what a hidden node problem is, when clients arbitrate for airtime, when they roll the dice and figure out who is going to talk, when a device basically gains access to the medium and starts transmitting, they will transmit. They will tell everyone else on the channel to set a nav timer. They say, everybody synchronize your watches now, and everyone shut up for this much time so that I can transmit. If you've got a client, like Clayton said, that's way off on the other side of a wall or something like that, if you've got a couple of clients that can't hear each other, then one client will not hear the other client set a nav timer. And so then they'll both start talking. And that is a hidden node problem. Basically, it basically causes collisions. Cool. Well, I think we went through that one. I think we got everything we need on that one. So I'm just going to keep going down the list here. Let's see. Brian, as many modern environments continue to prune 802.11b legacy rates, how significant is the Wi-Fi SSID overhead calculator in these modern environments? Very, very good question, Brian. Jerry, Clayton, any thoughts on that?
Yeah,
we were causing a collision there.
Yeah, look at that. Hidden node problem.
CCI.
So who's going to talk? Set your nav timer, gentlemen. We were talking about this yesterday, and that comes down to the SSID calculator that we were looking at. So, the question comes down to how high do you go in pruning your data rates, right? It'd be fantastic if you could prune your data rates all the way up to 54 meg, but the reality, the application of that, it's not really possible because you can't really achieve the SNR. So it's not necessarily about the data rate, it's about the SNR in the environment. Right.
Jerry, do you still have that calculator handy?
Yeah.
It would be fun. Yeah, it'd be fun to crank that up to 6 megabits per second and look at the difference between, how much time we consume on the channel with beacons at 1 megabit per second versus 6 megabits per second. How much does that change?
Yeah. So
is that easy to do in the calculator?
If you raise it to 6, you said?
Yeah.
Yeah, it's going to make a big difference, right? So even if we just go from 1 to 2 or 6 to 12, we're going to see drastic differences. One of the questions that I often get that we haven't really talked about is, why don't I just crank this thing up to 54 then, right? Look at how much better things are. And obviously this is a give and take kind of thing, right? And how do we determine that? Clayton, what do you think? What would be the process of figuring out what is the optimal data rate, to prune those low data rates? How do you figure out what low data rates to potentially prune in an environment?
Boy, that's a great question, Jerry. One that has stumped me at the moment.
So I think to me, the first step would be doing a site survey, right? And now you have a lay of the land of, really it all comes down to SNR. So if we don't have SNR to support that speed, we can't prune that level of data rate. If we can ensure that our clients are all going to have a certain level of SNR, then we can raise the bar and increase that. If you look at, there's a good chart out there for it. Joel, I don't know if you know which one I'm talking about, where it shows.
I don't.
It correlates MCS rates to SNR. And, I don't know how accurate it is, to every client is going to be somewhat different, but at least it gives you kind of a guideline of, let me see, MCS to SNR.
This is totally another Revolution Wi-Fi one, isn't it?
Probably. There's
Yeah.
all sorts of good stuff on this from Andrew. Let's see if I can find it real quick. Yeah, here he's got actually it's from Revolution Wi-Fi, but it's on. Oh, it looks like it's also on Revolution Wi-Fi's website.
Yeah, 2 links there.
You got them in there. Cool. Yeah, so there's a good. Thank you. Yeah, so that's the SSID Overhead Calculator, and then there's this Revolution Wi-Fi where he maps MCS rates to SNR, and you got your MCS chart here. But there was a different one that I was thinking of, but this works as well.
Yeah, I didn't post a link into this one because I'm not sure this is the one that we were talking about. That's the one on Keith that Keith's got up on the WLAN Pros. I'll post a link in there for that one. Yeah. That is the right one, right?
Yeah.
Okay, I'll post a link. Actually, you know what?
That is a good one, but yeah, that goes.
Brian Swanson beat Brian, or no, Petros didn't.
Yeah, there it is. So yeah, that's the chart that's going to correlate your what MCS rate you can support based on the SNR, and then that's where we can derive that how to kind of fine tune and optimize those settings, and basically kind of raise the bar, make sure our clients aren't talking at that lowest data rate, our management traffic isn't being sent out at that lowest data rate if it doesn't need to be. Now, yeah, exactly. You don't want to just go in there and crank this thing up to 54 megabits per second, because if your clients can't talk that fast and you can't support that kind of an SNR, we need to allow those clients to be able to rate shift and support lower data rates. So it's a balancing thing, right? So one thing that you can do, and that I know people have done, is you kind of raise that bar up to a certain level and you do a packet analysis and you see things like, what are your retries like? And you kind of play around with that number and you try and fine tune that of raising that bar as high as you can while keeping those retries as low as possible. And once you start to see those retries increasing, now you've pushed the limits too far.
Yeah, the way that I kind of like to think of it, when you start pruning off legacy rates, your coverage cells basically shrink. And the RF is still doing the same thing that it did, but the area in which a client device will successfully be able to decode a transmission, that area shrinks. And so really important, if you start pruning data rates, to make sure you go validate it, make sure that your clients can still talk to the APs, make sure you've got enough SNR. I've honestly never seen that chart before, so I'm excited to spend some time looking at that later to see, I just want to learn more about that. Really good question from Eric that I think is pretty applicable here. When you have legacy clients to support, like via wireless phones, vendors that put a 2.4 radio in because it's cheap and they don't know better, et cetera, is it better to create a separate 2.4 only SSID and limit it to certain APs or areas of the facility? Or should you keep it all in the same SSID across all APs in the facility? Jerry, Clayton, any thoughts on this one? I have thoughts, but I'll let you guys answer this one, I think. Or maybe you don't, and maybe I will answer it.
You go ahead.
Tell you what, I got it since I'm looking at the question here. Eric, if you run the same SSID in both 2.4 and 5 gigahertz, one thing that you may run into is your client devices, and when I say may run into, I mean you will run into this. Your client devices will often misbehave and they will associate on the 2.4 gigahertz band. In fact, that happens to me occasionally here at home. I'm running the same SSID on 2.4 and 5. And every now and then my MacBook will associate on 2.4, and then Jerry makes fun of me for being on 2.4, and it's awful. You don't want to be in that position. And so generally speaking, it is a good idea to run a 5 gigahertz only SSID and a 2.4 gigahertz only SSID, and that way you can essentially lock your clients to the band that you want to. If you are allowing users to select an SSID, one little trick that I have used, I call this socially engineered band steering. With socially engineered band steering, what I do is I call the 2.4 gigahertz network Joel's network slow, and then I call the 5 gigahertz one Joel's network fast. And when people get out their iPad and they're looking to see their phone, they're looking to see which network to connect to, they go, well, I don't want the slow one, and they'll connect to the fast one. Maybe not always, but you'll typically get them over to the up to the 5 gigahertz band. Now you can turn on things like band steering. The way that I think band steering works with most vendors, if not all of them, is that an AP, when it hears a probe request from a client device, if it hears it in 2.4 gigahertz, it will ignore the first 2, 3, 4, 5, 6 probe requests in 2.4. It'll just ignore them, thus encouraging that client device to go probe in the 5 gigahertz band, and then it will reply in the 5 gigahertz band right away. The problem that I've seen with that is that it seems to increase the amount of time that it takes for a client device to get associated. And so that can also introduce roaming problems and things if you've got a client or a 2.4 only client can run into roaming issues. At least that's the experience that I have. Let us know in the chat if you've had a similar experience or not with that. So I hope that helps. Let's see, Jerry, I see you poking around on slides and stuff over here. You want me to keep going with questions, or what do you think?
Yeah, I think we got time for a few more questions. I see it's the top of the hour here, but we've got plenty of people on and plenty more questions here. So maybe let's answer another couple more questions.
Awesome. Next really good question. Clayton, I'm going to throw this one at you specifically, Clayton, because I think that you've got good answers here. Simon says, I'm a student and I need some good training like this, but entry level, any advice? Clayton, I know you've been going through a bunch of different courses and things lately. And so what would you recommend for somebody that's just getting started in this? What kind of training would you recommend for them?
Yeah, I've actually seen some good responses to this. So I've seen several people mention in both chat and responses in the Q&A over here is the CWNA track, right? And I guess this all depends on what vendor technology you want to focus on, right? So if you focus on a certain vendor, like I started out with my CCNA because I was focusing on Cisco at the time, right? But the nice thing about CWNA is it tends to be a little bit more vendor agnostic. So you're not specifically learning how, Cisco handles things. You're learning how everybody else handles things. Because then you run into situations like Joel mentioned where you're like, wait a second, a different vendor handles band steering in a different way than, the one vendor that I've been focusing on. So CWNA is a great place to start. Twitter is another great place. Get connected with the wireless community on Twitter and just ask questions. I ask questions every once in a while, and I'm like, hey, how does this work, right? Or what do you guys think about this? Or have you ever run into something like this? Or to Joel's point, how do you guys separate out?
Oops.
Whoa, we just lost Clayton. That was just like a hard loss there. But I think we all get there he is. He's back. Hey, Clayton.
That was my fault.
Welcome back.
Jerry just kicked me out. I saw that. It was like, the host will let you in soon. I was like, oh.
Wow.
I guess it wasn't
It was totally my bad.
I guess it wasn't a good
Jerry's
answer.
just like, I'm tired of hearing Clayton talk.
You're done.
Like, no, this is not a good answer. We're gonna.
But yeah, Clayton, sounds like your recommendations are CWNA, whether you just go buy the book on Amazon. I refer back to my CWNA study guide all the time. I recommend the David Coleman and David Westcott version is excellent. CWNA boot camps. Love one of my favorite instructors in the space is Robert Bartz. He is Bartz. Robert is one of my favorites, and he's a great instructor. You can go take a boot camp with him. Also, we offer a course as well called the ECSE Design, the Ekahau Certified Survey Engineer Design course. What I love about the ECSE Design is it's not so much of a here's how to click on stuff in Ekahau. It's more of a here's how to design and deploy great Wi-Fi. We just happen to use Ekahau in the course. So that's my recommendation. And of course, all of the Wi-Fi vendors out there, they all offer excellent training programs. Timothy just posted in the chat about Aruba network stuff. Timothy, I need to take some Aruba training. I need to do that. So maybe you and I should talk at some point. So cool. I think we've probably got time for just one more question. I'm going to throw a difficult one out here that, to be honest, I have no idea how to answer this question. So Brian, we'll do our best here and we'll see what we can do. But Brian asks, how do you expect RxSOP and eventually BSS coloring with 802.11ax to contribute to co-channel interference? Jerry and Clayton, do you guys have any thoughts? I honestly have no experience with RxSOP, and I know that BSS coloring is coming in 802.11ax, but man, I'm just not sure the specifics on this stuff yet.
Yeah, so I heard a little bit about BSS coloring from someone that made me wrap my head around it. It's not so much that co-channel interference is not going to exist with BSS coloring. It's just that the standard is going to say, I don't care. So it's basically going to say, yeah, go out, transmit, whatever. It's fine. You're connected. I'm connected to a different, like two clients next to each other transmitting. Yeah, I can hear that client over there, but it's perfectly fine. You're connected to me. So just go ahead and transmit. Right?
My understanding of BSS coloring is that, so a BSS being a basic service set or an individual cell, coverage cell, that with BSS coloring, you can basically instruct your APs and clients to only pay attention to the stuff going on inside your coverage cell. And so if you hear on the same channel, you hear a distant coverage cell, you hear a conversation in a distant coverage cell between a client and an AP, you can essentially ignore that conversation. I don't think that it's going to change physics. I don't think it's going to change. I don't think it's going to fundamentally change how we do channel planning. I think that client devices are still going to have to contend for airtime. And if you have something else nearby that talks, it may still corrupt whatever you're saying, and you may still have a collision. That's my read on it. I don't know for sure whether that's accurate or not yet. So I think it's something I'd recommend, you go and investigate and look into yourself, which I plan on doing more of. And I think that I don't know much about RxSOP, so I don't think I can really comment on that one too much. Jerry, any closing thoughts?
Yeah, I'm not an expert on RxSOP either. I've heard some smarter people than me talking about it. Actually, it was briefly talked about at Cisco Live in one of the sessions that I was in. And usually anytime I hear somebody that knows about RxSOP, they usually have some kind of cautionary, mention in there of, use this with caution kind of thing. It's one of those things where, I've heard it kind of explained as, the AP putting on earmuffs in the sense that it's going to ignore certain things, or even like if it hears things at a certain level, it will ignore that and continue to transmit, right? Ignore it in the sense of resetting its nav timer. I'm sure somebody in chat can explain it a lot better than I can, but usually where I see RxSOP being played around with is in very dense environments, like stadiums and things like that, where you're really fine-tuning things. There's a cost thing where you're trading, you're basically inducing additional interference, which could be equating to higher amounts of retries and higher noise in the environment at the cost of giving the AP more transmit opportunities to be able to, So Bruce says it trades transmit opportunity for SNR. So that's really the simplified way of explaining exactly what I was just trying to explain. So thank you, Bruce, for that.
Maybe we should do a webinar about RxSOP, and we should just have Bruce get on and have one slide that says that. And that's the end of the webinar. It's like a 30-second webinar.
That is the simplest way, I think, to wrap your head around it, is you're trading off SNR for more transmit opportunities. So lower SNR, but increased amounts of transmit opportunities.
Cool. Well, I think we are about 8 minutes past the hour here, and so I think we should probably go ahead and wrap this one up. Jerry, Clayton, thank you so much for this. Definitely great to talk through all this stuff with you guys as usual. Great content here. Enjoyed the demos and things. Audience, just a few closing notes here. If you want to watch part one, then head over to the Ekahau website, ekahau.com. Click on training, click on webinars, and you will be able to watch part one. This webinar will be posted in usually it's 24 hours, but typically even faster than that. Our marketing team's really quick about getting this stuff done. They will get this posted. If you have any more questions for us, then please feel free to reach out to us. My email address, joel.crane@ekahau.com. Clayton's email address is on screen. Jerry's cool, and he just gets jerry@ekahau.com. But if you have more questions, please feel free to ping us on those. We would be more than happy to talk. One thing I want to alert you of that's coming up in a future Ekahau webinar is we're kicking around the idea of doing an open forum webinar. And so if you think that these webinars are casual, just wait. There's more. We're talking about doing one of those, and so just keep an eye out. We'll post announcements about that on Twitter. An open forum would be perhaps a time where we can just talk about random topics.
So you're saying instead of pre-webinar banter, it would just be a banter webinar.
A banter webinar. That's exactly. And Jim
all the time.
Jim says it's a way for you to prepare even less for these. Jim,
Bruce says
stop it, Jim. A bantanar.
Banternar. I like it. There we go. We got a title for it.
All right. And on that bombshell, I think it is it's time to end. Thank you everyone so much for being here. We will look forward to seeing you on a future Ekahau webinar. We'll see you soon.
Awesome. Thanks, guys. Appreciate it. Had
Thanks,
fun.
everybody.
All right. Talk to you later.
Bye now.